This one is the impression creep testing setup, where we are starting with the power supply, and the power is coming in the rheostat, where we can control the power, and the power is going to the ammeter cum relay, where we can control the current and we can set the temperature, the temperature what is desired. So here in the relay, whenever we are particularly desiring a particular temperature, specific temperature, after reaching the temperature, it gets cut off, and then again when the temperature comes down, again the power gets on and it starts to heat up. So we can attain a particular desired temperature by means of this relay. So this is ammeter cum relay, and which is actually getting the power supply from the rheostat. Here we have a fabrication unit entirely, where this part, these are all the structural members, and this is a cylindrical furnace. This part is a cylindrical furnace. Inside this one, we have fabricated a furnace in such a manner so that there is a cylindrical groove through which an alumina rod can move inside. See, this is the alumina rod. Now, inside this groove, we are keeping an alumina plate, and above that we are keeping a sample, and above the sample, so we are keeping this alumina rod. This particular alumina rod is having an indenter to indent on the sample at that particular desired temperature, and that indenter may be made of alumina or tungsten carbide and so on. The material we are using alumina for the rod and the indenter, because this alumina will not deform easily in higher temperatures. So we have this furnace chamber inside the and we have made this furnace chamber. First of all, we have just outside the furnace chamber, we have made it by the canthal wire for as a heating element we have used, and outside that we have used the what is called ceramic wool as an insulator. So we have fixed the canthal wire with the alumina tube with the paste called sodium silicate plus alumina powder we have used as an adhesive, and outside the alumina tube, so we have placed the ceramic wool as an insulator. So the furnace chamber is made of that alumina tube, and inside that alumina tube, this alumina rod may reciprocate. So here there is a bearing, so which guides the movement of the alumina rod, and it ends up with a plate, so which bears, we can bear a desired weight. So whenever, so we are giving an indentation on the sample which is kept above the alumina plate. So the alumina rod and the indenter, so whenever we are giving this weight, a desired weight, it is giving a particular force or weight on the sample, and it is indenting. So, and we are maintaining a desired temperature by means of the, inside the furnace by means of the relay. So we can control the amount of load and the degree of temperature. So these two things we can give as an input, and our measuring output is the amount of indentation. That is, we can measure the indentation by means of a dial gauge. This is a dial gauge what we have fixed over here, and here, so it is a mechanical dial gauge that is connected at the bottom of the rod. Over here we can see that the flange, at the bottom of the flange, here the dial gauge is connected, and it will measure the minute indentation that is happening on the sample by means of the alumina rod and the indenter. So this mechanical dial gauge we are using to measure the indentation. So this is the relay to control the temperature. This is the mechanical weight that we can put on the sample, and we can measure the creep. So obviously at high temperature the deformation will be the creep mode. So due to creep, the amount of indentation we can measure by means of the dial gauge. Now we can vary the load and the temperature, and at different loads and temperatures we can measure the indentations at the creep indentations. So this impression creep testing method is a much more easier, simpler and a cheaper setup compared to the normal pre-testing setups. So this is all about the impression pre-testing setup, which is fabricated in the material science lab of mechanical department, Tezpur University.